Welcome to our third lecture in Computer Programming Part 2. We're going to have a series of lectures that cover a very large topic, which is inheritance in Java. So in this lecture, I'm going to show you where to find some slides and some resources on my website that talk about inheritance. I'm also going to show the assignment. We'll go over that. And the example that I'm going to do on this recorded lecture will be very similar to your assignment. So that's why I'll go over your assignment first, and then I will explain what I'm doing and how that relates to your assignment. So first, the slides, and again, these are a little dated. These are slides I put together about 10 years ago when I started teaching this class. Back then it was called, I think, Java 2, and has gone through a few iterations since then, but nonetheless, inheritance and polymorphism still applies. So ucjava.com, and then towards right about here, click on 32IT206, and again, you see that course number is a bit out of date. College 32 no longer exists, but nonetheless, this is the stack of slides that we're going to go over in this lecture and the lectures that follow. Inheritance hierarchies, fields and methods, polymorphism, dynamic binding, abstract classes, so on and so forth. Now, last quarter's class, Computer Programming 1, we learned a lot about syntax. In this class, we're really learning how to be artists, how to apply that syntax. This set of slides and the words that you see here, inheritance, polymorphism, dynamic binding, abstract classes, I will guarantee if you take a job in this industry, you'll come across these words in a technical interview as the bare minimum things that you need to know to go on to the next step. Many times what will happen if you apply for a job is, employers will get a lot of applicants, and there's a several stage process to make sure that only qualified applicants actually get in the door. So many times there'll be a resume screen where somebody will just look through resumes and see who has relevant experience or education. Next, there'll be a phone screen, and the idea there is just spend 15-30 minutes to decide if that person goes to the next step. After that, there will be an in-person interview. And naturally, an in-person interview is expensive for the company doing the interview and also for the person showing up. If you figure that's several hours out of each person's day, that's something that, once you get to that point, you're kind of in the top tier of candidates. So what we're going over now will be material that you would probably see in a phone screen, material that's going to get you to that next step. So I have to stress, it's important to commit this material to memory because you'll probably see it again, but not from me. You'll probably see it in an interview. So it's all that much more important to do quiz question suggestions on material like this for that reason. So that's what we're going to cover. And remember that we're going to spend about the first half of this quarter really building up to an example. And I mentioned in a previous lecture that when we go through object-oriented design applied, which will be a few more lectures away, when we get there, some people will really get it and some people will be utterly confused. And my goal and your goal at this point should be to try to maximize the number of people who really get it and minimize the people who are really confused. If you get it, if you're one of the people who gets it, then you're going to be well prepared for the following classes that are going to come in computer programming and for a career in computer programming. If you don't get it, it's going to be more of a struggle. So that's why I say my goal and your goal at this point is to try to maximize the people who really get it, maximize that number of people, minimize those who don't. And everything that we're doing building up to this is going to support that goal. Okay, the programming assignment, as we have it here, is adding inheritance to the loan calculator program. At this point, we don't know what inheritance is because we haven't discussed it yet, but that is our material for today. So we want to continue working with the programming assignment part 1 that we built, and we're adding on to it with the part 2. We already have a class called account with a balance, rate, and period attributes, and a method called calculate. Okay? And what we want to do is we want to extend this. And this is what inheritance is. We want to extend account with a class called savings. And we want to extend account with a class called checking. And we want to extend account with a class called certificate of deposit. Okay? So that's what inheritance is, and that's what we're going to look at today. What does extend mean? What is a superclass and what is a subclass? What is a parent class? What is a child class? So that's what we'll take a look at today. And as I mentioned, my example is going to mirror this very closely. Okay? The class called banker will still exist, and the requirements for banker are similar. The difference is that we have to give an opportunity for the user to decide, do I want a savings account? Do I want a checking account? Or do I want a certificate of deposit? Okay, and then of course the grade sheet. So, what is inheritance then? What we'll find, and let me recenter this so I can maximize what's on the screen. What we're going to find is that many times we have our classes that represent nouns. And sometimes we want to make generalizations. So we might have things like a Cavalier, a Neon, and a Prius. Well, think about those. What do they have in common? They're all going to have a gallons of gas attribute. They're all going to have a miles per gallon. Okay, and they're all going to have an odometer. Those are things we would put in the superclass, or what we'll call the parent class. Things that are general to a set of classes, we will put in a superclass or a parent class. On the other hand, there are things that are specific to each of those vehicles. Okay? A Prius obviously is a hybrid. And so it has other things it needs to consider, like is it running with gasoline or is it running with a battery? What is the charge of the battery that runs the car? Not the one that starts the car, but the one that runs the car. Okay? The Cavalier. Okay, well, if you think about, and I'm kind of old school, so Cavalier, was big in the 90s and the 80s. Now it's a Cobalt. I think they still make the Cobalt, but back in the 90s, you could get a Cavalier, which was a fairly basic, inexpensive car. But then you could also get it with a convertible. You could also get the Z24 edition, which had a bigger engine and a more graphical trim. So these are things you couldn't get on a Prius. To my knowledge, you can't get a convertible Prius. So an attribute that describes a car as convertible would belong only in a Cavalier, where an attribute that says what's the charge of the battery that drives the car would belong only in Prius. Now we have the other car, and again, this is an example I've used for many years, so I'm using cars that are no longer made new anymore, except for the Prius. The other kind of car, and I'll confess that this was my car in college. This specific color was hard to find. Teal, green, neon, 1995. We'll see if we can find one. I had a, not that kind of green. That looked just like this actually. Yep. A not very masculine looking teal green neon. And this was for Dodge, that was their economy car. For what I spent on it, I was quite happy with what I got. But my neon did not have any options. And when I say that, there are certain things you assume that cars just come with today. And my neon did not. It didn't have a passenger side view mirror, the one that hangs off the door. There was none. It did not have a radio. It did not have air conditioning. It didn't have power steering. So again, things you think cars just automatically come with. My neon didn't have any, but again, I was in college, paid for the car myself after working 2 jobs over the summer, and it's what I could afford with the money I made that summer. And I was quite happy. One of those 2 jobs that I had over the summer was at Radio Shack. And While the car didn't come with a radio, of course, I put one in it. And while the car didn't have any options, I had the best sound system in Butler County at the time, I can assure you. Needless to say, a Neon is the most basic car you could get in 1995, especially the Neon that I had is the most basic car. Is there anything a Neon has that a Cavalier does not have? Not really. When you think about options, not really. There were different trim levels like the Sport and the Highlander, or the Highland, I forget, the Espresso, and then mine, which just had no trim level. It was just basic. Um, but really, a Neon is very basic transportation. So now, how does this apply to your programming assignment? Well, programming assignment number one, we said make an account. Okay, we didn't say what kind of bank account, just make an account. Well, imagine if you went into a bank and you said, I want to open an account. The first thing the banker's going to ask you is, what kind? Okay, this concept of account is too general. You don't just say an account. They're going to say, what kind? After that, of course, they'll try to sell you a credit card too if they find out you have good credit, but nonetheless, they're going to ask, what kind? Now, what kind of accounts do we have? Well, okay, there's a savings account, which is just a basic account. You know, no frills, it's just a basic account. It earns interest, no checks, nothing like that. Then there is a certificate of deposit, which is like a savings account, but it has an additional attribute, and that is the length to maturity. In other words, you agree to keep your money on deposit at the bank for a certain amount of time, which we call the length to maturity. And for doing that, you earn a higher rate of interest typically. So a certificate of deposit will typically earn a higher rate of interest than a normal savings account will. So it has an additional attribute. How long are you agreeing to keep that money on deposit at the bank? Okay. And then a checking account. Okay, well, that has a bunch more attributes. What is the starting check number? Again, when I worked in retail, there was a lot of fear about people opening checking accounts and then bouncing checks and then skipping town. And so retailers generally had a rule. They wouldn't accept checks if the check number was less than 300. Well, that becomes the thought was that if you spent 300 checks, you were probably not someone who just opened the account and ran. Naturally, there was a problem there, is that nobody would accept these checks that with a number of less than 300. So the response from the banks was when you would open a checking account, they would just ask you, what would you like your first check number to be? And if you said 500, the first checkbook you got from the bank would have a check with a number at the top, 500, and then the next would be 501, 502, so on and so forth. So it was kind of a joke. You could start a checkbook with whatever sequence number you wished. You also might have something like a monthly fee. These are things that it's funny. We used to always think that checking accounts came with a monthly fee. Then in the late 90s through about 2010, checking became free. And then the Dodd-Frank Act came in, and guess what? We have to pay for our checking accounts again. So this is something that's coming back, this concept of having to pay a monthly maintenance fee on your checking account. So uh, checking accounts are the most complicated type of account that we have. Let's compare that to my car analogy. Savings account is the most basic. No real options beyond what a basic account is. That's just like my Neon here. Okay? A CD has slightly more options than a Neon, okay? Because you have that length to maturity. Well, that's just like a Cavalier. A Cavalier was just like a Neon, except it had a few more options like Z24 and convertible. You couldn't get a convertible Neon, okay? So Neon is to a savings account what a Cavalier is to a certificate of deposit. And then we have the most complicated thing of all, which is the Prius with its hybrid mode. And that's just like a checking account because the Prius has additional attributes that other accounts don't have, like am I running on the car's battery? what's the battery charge. Where a checking account has additional attributes that other accounts do not have, like what's the starting check number, what's the monthly maintenance fee. So many times our goal in programming is to take these complicated situations and try to make them simple through programs. Try to model them with programs. One of the modeling tools that we can use is something called UML. I'm using something here called Argo UML. This is, I like Argo a lot. Number one, it's free. It's an open source product. Number two, it's written in Java. Number three, you can run it on your computer but launch it from the web. Or you can just install it on your computer. But you don't have to install it, which makes it really nice. You just go to argouml.tigris.org. 1 second, I'll take you there. argouml.tigris.org. And you can either download and install it, like you see here, or you can just click and launch it straight from the browser. So it's a very nice tool, and it can help us to model our programs. This is what we're going to call a class diagram, and I'm going to model the program that I'm going to build for you today. We're going to start this little thing with 3 compartments as a class, okay? And I'm going to call this driver, okay? And, okay, I'm not going to worry about attributes, but if I had attributes, they would go in the middle. Methods go towards the bottom, so we remember that prompt user is a method that we use to prompt the user for information. By the way, this is exactly what we did last quarter, and it's what I usually do in Computer Programming 1. Nonetheless, it's probably good to redo it as a refresher, especially because I know some people haven't taken Computer Programming 1 in a little while. Additionally, I'm going to make one small change just because it's going to fit better with my quiz pool, and also I like the name a little bit better. Instead of vehicle, we're going to call it a car. That just seems to fit better with what we're going to do this quarter. So, prompt user is our user interface class, and remember, it's very important in programming to separate user interface logic from business logic and data logic, because the user interface is likely to change over time. You know, between mobile phone and internet and PC and every other interface type we have, we can maximize our reusability if we keep our user interface separate from our data and our business logic. So I'm going to click, actually I'll tell you what I can do. I'm going to click this solid line here. This is what we call a uses a line. So driver uses a car, okay? And in the car, I'm going to put our, let's see if I can scroll this up and get a better view of it on the, there we go. Okay, I'm going to put the attributes that we have. We're going to say odometer, okay? And then I'm going to click here, and what I can do is I can right click and choose add new attribute, and I can say, we'll call this one miles per gallon, there we go. We'll make that a double, okay? And by the way, this UML is not Java specific. This is for any programming language. So the data types you see here, like we have a capital D on double, in practice we might actually use the primitive type with a lowercase d. We use the uppercase D here, or maybe something else, because this is language independent. Other programming languages might have different ways of calling a double. Okay, right click, I choose add and new attribute, and we'll call this one gallons of gas. Actually, you know what, that should be a double. And this can be an integer, because usually we round miles per gallon to the nearest integer. Now, we'll make getters and setters for this, but to be honest, for each of these attributes, but to be honest, that's such a given that we don't actually have to put the methods down here. It's kind of a given that we're going to have getters and setters. We don't need to list the individual methods separately. Okay, I'm going to pull this down, and we're going to say driver, this is what we call a uses a relationship. So driver, I could put a label here. Let's see, see if I can put one up here. driver drives a car. Okay? We're going to see a new symbol that we haven't seen before, and that is the extension symbol. What I'm going to do is I'm going to mouse over this car class, and you see this arrow pointing up. Okay, I click on that, and it gives me another class, and the arrow pointing up. Okay, this is the subclass. This is our subclass, and we're going to make this one a neon. Okay, so at the start of the arrow is the subclass. At the top of the arrow is the superclass. It's a little weird because sometimes you feel like the arrow might be, it's kind of funny how the arrow points. You'll get used to it. So the subclass is at the bottom of the arrow. The superclass is at the top of the arrow. Okay, so here's my neon. And notice that all of the attributes in car are general to all cars. Thus, odometer, miles per gallon, gallons of gas, each of those applies to a neon. Also to a Cavalier, also to a Prius. Okay, so we don't need to redeclare them down in neon because this is an important lesson, an important theme. A child class will inherit all of the non-private attributes of the parent class. And by the way, you'll hear me use child class and subclass. You'll hear me interchange those. Superclass and parent class, I'll interchange those as well. They mean the same thing. This is what we call a child class or a subclass. This is what we call a parent class or a superclass. Use whichever word you want. It doesn't matter to me. It all means the same thing. But if I say child class or subclass, I'm talking about the same thing. Okay, now we're going to extend the car again. I'm going to mouse over and click on the arrow here, and it's going to give me another opportunity for a subclass. This one we're going to call Cavalier. And remember, there's one thing that a Cavalier has that a neon doesn't have, and that is the opportunity to be a convertible. So I'm going to make an attribute called convertible. Okay, and we'll make that a Boolean. And there we go. Okay, so notice that because it's down here in Cavalier, it's not accessible to neon. Cavalier still inherits everything up in the superclass, plus it adds its own more specific attribute called convertible. Okay, let's add one more, the more complicated of all. I'll once again mouse over, click the down arrow. And by the way, this down arrow indicates an is-a relationship. A neon is a car. A Cavalier is a car. And a Prius is a car. Okay, for Prius we know we need a couple of special attributes. One of them is, we'll say, MPMAH. Miles per milliamp hour. One of the classes I always wanted to take in college was something in electrical engineering. And one of the classes I always really wanted to take in high school and college was physics. Believe it or not, I have 3 degrees now and never took either. 2 of the courses I really want to take, never took even introductory physics. I regret that. Someday I will. But needless to say, I always have a question. How do you measure a battery's charge? I don't know. So finally somebody told me in class once, well, you could measure it in milliamp hours. All right, sure, works for me. So miles per milliamp hour is how many miles will we get out of a milliamp hour in the battery. And then we probably want another attribute. So I'll say add new attribute, and we'll say battery charge. Okay, and there we go. Notice that the attributes specific to Prius are here in the Prius class. They can't be used by Cavalier or Neon. Okay, what's specific to Cavalier is in the Cavalier class. What's general to all is in the car class. You only need to declare the attributes once, and they will be inherited. In other words, the subclass will have access to the superclass's non-private attributes and methods. So that means something that's public or protected. We don't know what protected is yet, but we're going to find out soon. The subclass or the child class has access to the parent or superclasses, non-private attributes and variables. So this is the inheritance hierarchy, or the class diagram, for the car class that I'm about to create. This is exactly, almost exactly, what your homework program is going to look like as well. Instead of driver, your class that is the UI class is going to be banker. That banker class should have all of the input and output. In other words, all of the J option pane, all of the system.out.println should all be in driver. If I see a J option pane or a system out print line outside of driver, it will be a point deduction. So make sure any interaction you have with the user is in class driver. Okay? Now, my car is going to be your account class. You see I have odometer, miles per gallon, gallons of gas, and then I will have a method called go. I should add that here now that I think about it. Go integer distance. Okay, good. Let me do that. Okay. The go method allows us to move the car a specified distance. You'll have a very similar method, but it won't have a parameter variable. Your method is calculate. Okay? My Neon is a very basic car without any frills, without any additional logic. That's just like your savings class. A savings account is a very basic banking account. My Cavalier is just like an account, but it adds one more unit of complexity, and that is it a convertible or not? Okay? That's just like your certificate of deposit. It's a basic account, but with one more piece of information, and that is a length to maturity. Okay? Length to maturity means when can it be taken, when can money be withdrawn penalty free. One major note, don't confuse length to maturity with number of periods. Okay? Number of periods, if you have a 5-year CD and you're curious how much interest you'll earn after 3 years, and let's say each year is a period, then the length to maturity is 5. The number of periods is 3. Okay, you just want to compute how much interest you've earned 3 years into a 5-year CD. Okay, maybe you want to compare the rate of one bank's 5-year CD with another bank's 3-year CD, for instance. So the number of periods is the number in which you're going to calculate interest. And then the length to maturity means this is when the CD matures and you can either roll it over into a new CD or you can withdraw the money penalty free. In theory, you can withdraw the money before that period, before the CD matures. You just have to pay a penalty for it. And as I recall, I've never done it myself. As I recall, it's usually just 2 times the interest, which these days is not a lot of money. Okay, the Prius has a lot of extra logic. It has miles per milliamp hour and battery charge. That's just like our checking account, because checking account has things like a starting check number and a monthly fee. And we're going to see that this is going to get even more complicated because we're going to add a method called go that looks exactly like the method upstairs in car. This is what we call overriding, a very important concept, because our method go in car is always assuming we're using gasoline. But the Prius has special behavior. It might be running off the battery and not using gasoline. So we have to override the method called go in Prius and put special logic in there to tell it to decide whether to use the battery or the internal combustion engine. This is just like the checking class. With the checking class, you have to override the method calculate, and you have to account for the monthly fee. So to override, you put an exact same signature of the method in a subclass as you have in the superclass. We'll see an example of that in a moment. So that's our design. We're nearing the 30-minute mark now. I'm going to go ahead and save this lecture, and in our next lecture, lecture number 4, we'll actually start to put this together. Also, we'll take a look at the slides as a quick review. We'll take a look at the slides that we have. We already started looking at them, and honestly, there's not much to it. We'll look at these as we need. I will point out there is an in-class exercise. This is not for a grade, but if you want extra practice, I have a little exercise here you can try. along with an answer key. So if you want yet another example, here's another example here. Very similar. Pet runner, that's like our driver or our banker. And then we have pet, which is like our account or our car. And then we have cat, which is like our savings or our Cavalier. Savings are our neon. Dog, which would be like our certificate of deposit or our Cavalier. So lots of things going on here. Most of these, I don't really read from slides much anymore because I don't think that adds a whole lot of value for me to read something to you. But needless to say, these are here for a second reference if you'd like another reference. Thanks, and we'll see you in lecture number 4.